All right, now we're going to talk about exponents for Module 2, Homework 5. So, exponents are allowing us to write repeated factors just in a condensed form. So 2x to the power of 10 means that this x is repeated 10 times. Okay, so in this expression here, you have an exponent. That's the number that's up in the air. So the exponent in this case would be 10. Your base is the number being repeated. So the base connects to the exponent. So the base here is the x. And then the number in front of the exponent and base, that's going to be a coefficient. Oops. Okay, so if we look at these two examples down here, is the first thing I want to point out about exponents is I just want to show you what these look like in our calculator first. So here you have a negative 5 to the fourth. If I put that in my calculator, I would do negative 5. This is my exponent button. This little chevron right here, or caret, to the fourth, gives me negative 625. Versus parentheses, negative 5 to the fourth, gives me a positive 625. Why is that? Yeah, well, yeah, even here, this one, what's the difference in these? I put a parentheses here, right? Okay, so this is one of the things with exponents that we're going to have to be very careful to pay attention to. The exponent is only connected to the base, meaning if I circle the exponent in the base here, that base is just a 5. Whereas here, the base is a negative 5. So this is negative 5 times negative 5 times negative 5 times negative 5. Negative times a negative is a positive. Negative times a negative is a positive. So that turned to a positive 625. Now here, this negative sign in front of it isn't connected to the 5. If it were, there would be a parentheses. Because, let's think about order of operations. What does this E stand for? What does the M stand for? The E comes before the M. We do the exponent, then we multiply, then we add this negative. That negative is like saying this. Negative 1 times 5 to the fourth. 5 to the fourth is 625. So we do negative 1 times 625. We get that negative 625. That's why it was negative when I put it in my calculator. So if you want to raise a negative number to a power, you have to put it in parentheses. If there's no parentheses, rewrite it. That's a bad square. But rewrite it like that. Because that's really what's happening there. Okay, that's very important to do before we move on. We just want to make sure we remember that. Now let's talk about our properties. All right, so you got some rules with exponents. Okay, first is the power of 1. Anything to the first power is just itself. So for example, 5 to the first, just 5. Negative exponents. A negative exponent is going to become a reciprocal of itself. So meaning it will move across the division line is what happens. When it moves across the division line, there's no more negative exponent. So for example, if I have a 3x to the negative 2, it's moving across this invisible division line that exists right here, it goes down and it becomes a 3 over x squared, because the only thing that's going to move is the base with the exponent, not the coefficient. Or if I have a negative exponent that's in the bottom of something, so let's say I have a 3, just go 3 there, and then I have an x to the negative 1 y, I will move the negative exponent across the division line. So this x to the negative 1 would move up, and I'd have a 3x to the first, x to the positive 1 over y. So it moves across the division line. Power of 0, anything to the 0 power is 1. 100 to the 0, 1. Anything to the 0. So let's just say I have 64,683 to the 0 power, 1. Anything to the 0 power is 1. Even variables. Okay, next rule, I have the power of a product rule. So this is product rule, we like to call it. Anything with the same base that's being multiplied, you're going to add the exponents. Okay, so let's say you have an x squared times an x to the 6th. You will add the exponents together. 2 plus 6 gives you 8. And that's because these have the same base. Now, power rule will tell you that if you have parentheses and you have an exponent being raised to another exponent, you will multiply. So that's like saying if I have x squared to the 6th, that's x squared 6 times. So if I wrote that out, that would be x squared, x squared, x squared, x squared, x squared, x squared. So there I would multiply x to the 12th. So if they're separated with a parentheses, you multiply. If they're not, you add. And then quotient rule, when you're dividing exponents with the same base, subtract the exponents. So if I have x to the 6th over x squared, I do x to the 6th minus 2, I get x to the 4th. Now you're supposed to divide top to bottom, but I like to do just a little shortcut with that. See where the larger exponent is? X to the 6th is in the top. It'll stay in the top where the larger exponent is. Okay? So if the larger exponent's in the bottom, this would stay in the bottom. So then that would have an x to the 4th in the bottom because the 6th is in the bottom. And you would just put a 1 over there. Okay, it's just taking out a step in the middle, where if I did 2 minus 6, I would get negative 4. And then I would have to take that negative and simplify it using negative exponent rules. So it's just skipping over that negative exponent step there. So wherever the larger exponent is, that's where that base will stay. So what we want to do with these rules is we want to combine them all together and simplify all these exponent problems. So first, just a little more about negative exponents. We move them across the division line. Once they move, they're positive exponents. So for example, if I have x cubed over x to the 5th, and I do 3 minus 5, I would get x to the negative 2, just like I have here. But if you notice, if you write it out, 3x's in the top and 5x's in the bottom, and then you cancel out, like x's, you're left with x's in the bottom. Okay, so that's just to solidify that rule that subtracting these exponents, the larger base will stay where the larger exponent is. All right, let's do some examples. So when I'm doing these examples, the first thing I want to do is I always want to do the power rule first, which is distributing any exponents. And in number 1, I don't have that, so skip that. And then do the 0 exponent rule as well. 0 would be second. Okay, then you're going to take care of any negative exponents. So when I'm dealing with negative exponents, here's what I like to do. I like to just take this line and extend it, circle my negative exponent in the base. So that's just only going to affect that x, not the 4. The 4 is not connected to the x, or sorry, it's not connected to the -3. I take that and I'm just going to move it down here as an x cubed, and then I just cross this off. Now, if it's a really long problem, I'll rewrite it. This one's not that long, so I don't really need to rewrite it. So then you're going to do your negative exponents. Then you're going to do product and quotient rule. And then you're going to simplify numbers last. Okay, so that's the order that you would do to simplify these. Now going back to this first example, on the top I'm left with a 4. On the bottom I have x squared, x cubed. I have the same base. They're being multiplied. So I'm going to add. So it's going to be an x to the 5th. So this would simplify as 4 over x to the 5th. Okay, let's take a look at the second one. I don't have anything in parentheses and I don't have any 0 exponents. So I'm going to go to my negative exponents. I'm going to extend the line, circle the negative exponent in the base. So I have the b to the -5 in the top. I'm going to move it down to the bottom as a b to the 5th, and I'm going to cross it out of the top. In the bottom, I have an a to the -2. In the bottom, I'm going to move it to the top as an a to the +2, cross it off. Now I'm going to write what I'm left with. So I have an a to the 4th and an a squared in the top. And I have a b and a b to the 5th in the bottom. Now I can simplify using product and quotient rule. So my a's are being multiplied, so I'll add the exponents. It's going to be a to the 4 + 2, 6. What's understood with this b? That's to what power? 1. So that's going to be 1 + 5, b to the 6th. Now, even though it's have the same exponent, you can't do anything further there. So a is different than b. They're different letters. So a to the 6th over b to the 6th. All right, let's take a look at this next one. So we're going to start, we do have a power rule. Okay, so I have this -2 outside of the parentheses with 2 things in front of it. So it's going to distribute to both of these, multiplying as an exponent. So this is not 2 times -2. That is going to be 2 to the -2 power, because you're multiplying it by this exponent of 1 there, 1 times -2. And then for the y, you're doing 3 times -2, which is a -6. Okay, then you have your x to the 6th, and then you have x squared. Now I don't have any 0 exponents, so I'll go to my negatives, and I'll simplify them. So I have these two, both have negative exponents, so I'm going to move them down to the bottom. So I have a 2 to the +2 and a y to the +6. Okay, I can rewrite that. I don't really need to. It's pretty neat. Okay, so we have a x to the 6th on the top and x squared on the bottom. So that's quotient rule. Where's the bigger x? The top. So I'm going to subtract 6 minus 2. I'm going to get x to the 4th in the top. I only have one y, so that'll come down as y to the 6th. And I have this 2 squared. What's 2 squared? 4. I have one of each variable, 1x, 1y. I've got one number. So that's it. So x to the 4th over 4, y to the 6th. Okay. Lost my mouse. There it is. All right, let's look at this next example. So I have a negative 3x to the 4th times 3x to the 6th. Now, for this one, you've got separate, 3 and the x are separate. So what I would do is you can kind of write it like this, if you would like, just to see what's going on here. So take care of the x's first. X to the 4th times x to the 6th, that's going to be x to what power? 10. Good. So we're adding them. And then this is just negative 3 times 3. So what's negative 3 times 3? Negative 9. So that's negative 9 x to the 10th. So you're just going to add the numbers, add the exponents, multiply the numbers. All right, then we got this big one right here. So let's start with anything we have to distribute, which looks like right here. So let's see, you've got a 6, you have an x to the negative 3, then you have to distribute this 3. So it's going to be a y to the 3rd and a z to the negative 18. All right, then on the bottom, you've got a 3, an x squared, y to the negative 3, z to the negative 3. Okay, next I'm going to take care of any negative exponents. So I'm going to extend my line. Looks like in the top I have an x to the negative 3, a z to the negative 18. So I'm going to write an x to the positive 3 in the bottom, cross it out of the top, a z to the positive 18, cross it out of the top. Then in the bottom I have a y to the negative 3 and a z to the negative 3. So I'm going to write a y to the positive 3 in the top, cross it out of the bottom, z to the positive 3 in the top, cross it out of the bottom. Then I'm going to rewrite what I've got. So I've got a 6y cubed, I have another y cubed, and a z cubed in the top. In the bottom I have a 3, I have an x squared, x cubed, and a z to the 18. Okay, now I can start simplifying. So let's go in alphabetical order. We'll start with the x's. Where are the x's? Bottom. And I'm going to do what with those? Add. So 2 plus 3 will be 5. We have an x to the 5th in the bottom. All right, what about the y's? Yep, add these. They're both in the top, so that's going to be y to the 6th in the top. Now, z's, I've got 1 in the top, 1 in the bottom. Where's the z going to stay? Bottom. 18 is bigger than 3. What is 18 minus 3? 15. So I have 15 z's in the bottom. All right, now my numbers. What do I do with these? Yep, you just divide. It's just 6 divided by 3. So that's just 2 in the top. So there's your answer. 2y to the 6th over x to the 5th, z to the 15th. All right, before you turn the page, I'm going to give you 2 of them to try. Okay, so let's go, Okay, we'll do that one for number 1. Okay, so try these two. Give you guys a few minutes and then we'll go over them. All right, let's go over them. Okay, so for my first one, I don't have anything in parentheses to work out, but I do have a 0 exponent. So this is just 1. So I can just cross it out. Because 1 times anything is itself. Just a 1, it's just sitting there. Okay, next thing I'm going to take care of negative exponents. So it looks like in the top I've got this a to the negative 3. So that's going to go to the bottom as an a to the positive 3. Cross out. Then in the bottom I have this a to the negative 2. So I can move that up as a to the positive 2. Cross it out. So all my negative exponents are gone. Looks like I can take care of the problem now. Okay, so we'll start with the a's. Where's the larger a? The bottom. So 3 minus 2 is 1. So I can just write a. I don't need the 1. Okay, what about the b's? I've got b to the 4 over b to the 5. Where's the larger b? Bottom. So that'll be a b to the first. And then I just have 1c squared in the bottom. And then let's take care of my numbers. 3 over 12 is going to be what? 1 over 4. So 1 over 4. So 1 over 4, a, b, c squared. All right, number 2, you've got 2 problems here. So my first one, well, yeah, we'll just do this separately. So this one here, I'm going to take the a to the negative 2. I'm going to move it into the bottom as a squared. And then this here, this whole thing's over a negative 1. So I'm going to go ahead and distribute. You can move everything down if you want, or you can distribute. So this will kind of just go off to the side for right now. So this is going to be 6b to the 4th over a squared. And then let's work on this. This is going to be 18 to the negative 1. That's going to be a to the negative 3 times negative 1, so it's going to be a positive 3. And then that's 7 times negative 1, so negative 7. So then this, the 18 and the b to the negative 7 will go down. So then here's the problem that I'm left with. So I have that 6b to the 4th over a squared times, in the top here, a cubed, and then I have an 18 b to the 7th. Okay, now when I'm multiplying fractions, I can multiply straight across. So I really can just take this line and extend it. Then I can simplify. So for my a's, I've got 1 in the top, 1 in the bottom. Where's my larger a? Top. So this will be a to the first in the top. Okay, b's, 1 in the top, 1 in the bottom. Where's the larger? 7 minus 4, 3. So b cubed in the bottom. Then I have 6 over 18. What's that going to simplify to? 1 over 3. Now, since you already have an a in the top, you don't need to write that 1. You can if you want. But if you saw this as a multiple choice question, it wouldn't have it. So it would just be a over 3b cubed. All right, any questions on these? Good. Okay, let's talk about scientific notation. Have you guys seen scientific notation before? I don't know if they teach it in school anymore. Yeah? Have you guys ever done a problem in your calculator and gotten something like that with the E? That's scientific notation. Okay, so if you see that in your calculator, like, what is that? That means this is scientific notation. So what it is your base number, then it's times 10 to this power. So this means that I would take this decimal and I would move it out 16 places, is what that's telling you. So you have a base times 10 to a power. And all that's saying is when it's times 10 to a power is how many places am I moving the decimal? A positive number will move the decimal to the right. So if n is positive, we're going to go to the right. If n is negative, we're going to go to the left. And then this integer here, there can only be one number to the left of the decimal. So it's from 1 to 9.9. So it would have to be like 1.0 or 3.4, 2.78, 9.9. Only one number to the left of the decimal. So you couldn't have like a 48.6 because there's two numbers. So just you'd have to make that 4.86. Okay, so going from standard form to scientific form, you're just going to put your decimal with one number to the left. So here's the decimal now. You want to move it here where you have one number to the left. So you have 7.3. Once you get to zeros, you don't need to write the zeros, times 10, and then you're going to just count how many places this goes. So this goes 1, 2, 3, 4, 5 places, times 10 to the 5th. We want to count it from the standard to scientific form, to going left to right. Okay, so I went right here, so it's a positive. Another way to look at that is if it's a big number, it's positive. If it's a small number, like a decimal, it's a negative. So for this one, we're going to ignore the zeros. We're going to go where it would be one place, so right here. So that would be a 1.04 times 10. And then from your original number, we are going to go, let's see, 1, 2, 3, 4, 5, 6 places to the left. Sorry, from my scientific number to my original number, I go left. So it is a negative 6. So then here you have 5.6 times 10 to the negative 7. So you go 5.6, it's in scientific, you want standard. Negative is left. So 1, 2, 3, 4, 5, 6, 7. There's your decimal. Fill that in with zeros. So it should be 6 zeros and then a 5. 6. Then you have 3.4 times 10 to the 8th. So 3.4. We're going to go right because it's positive. So 1, 2, 3, 4, 5, 6, 7, 8. And then we fill that in with zeros. So there should be 7 zeros there. All right, computing with scientific notation. If it's multiplication, multiply the numbers, add the exponents. If it's subtraction, divide the numbers, subtract the exponents. So, or sorry, division. So this one here, we would multiply 5 times 2.9. So let's see. So it's going to be 14.5. And then you are going to take these and add them. So 10 plus -4 is 14. Then you have to put this in scientific notation. It's not in scientific notation. Why not? Yeah, there's two numbers here. So you got to make this 1.45, which means that I have another decimal I've got to go. So here I only had to go 14 to the right. I had to go one more. So I got to go 15 to the right. So you got to add one here. If you go that way, add one more. Yes. It's 18 plus -4, which means it's 18 minus 4. Because that's a -4 right there. So here our problem is 1.45 times 10 to the 15. And again, I assess that because okay, if I'm going from this form, I would have gone 14 places to the right. But I have to go from here over, which means I've got to go 1 and then 14 more. So 15 places to the right. And then here we have 24 divided by 4, which is just 6. And then times 10, and this would be -9 minus 7. So subtract top to bottom. So that would be -16. And you don't have to simplify that negative because we want this in scientific notation. So all that's saying is that's 0.015 zeros and then the 6. So 0.00000000000, I lost count, 6 is what that is. And that's it. That's scientific notation for you.